we're going to look at ratios and proportion. Let's start by looking at the situation here where I ask you to draw a solution to this question here. We have this board. Piece A is 1/3 as big as piece B, and so some questions here. Piece A is how much of the board? So most students are going to say it's 1/3 of the board, but if you look carefully, if A is 1/3 the size of B, that means that that A is 1/4. How much is the board? It is 1/4. As you can see, it's 1/4 of the board. Piece B is 3 times as big, as you can see. And so think about that. If you're in class situation, then you're going to go ahead and think about this with others here. Repeat the following scenarios for piece A is 3/4 as big as piece B, and then piece A is 2/5 as big, and see what that would look like. But this is the solution for the 1/3 situation. What we're going to talk about in this section is ratio and proportion. So what we look at right away is, what is a ratio, right? The concept of ratio occurs in many places in everyday life. And in this ratio, we use the word per. So for example, cents per ounce, dollars per hour, miles per hour, right? How fast you're going. And so this word per means for every. And so for this first example here, we're just looking at different examples of ratios. And so you can read those here and how they're displayed for us. And again, a ratio is looking at the definition below. A ratio is an ordered pair of numbers written A, colon B, or sometimes you write it as a fraction, which we're going to see right now. But in this example here, you'll see different scenarios. What I want to look at is this one here. What does this mean? In Smithfield, the ratio of girls to boys is 3:2. So that doesn't mean that in the classroom there are 3 boys and only 2 girls in the class, right? What we're looking at is that the ratio is 3:2. So that means there could be 3 and then 2 girls, or there could be 6 boys and 4 girls, or there can be 9 boys and 6 girls, right? And so you have these different types of situations of what the ratio is. So you have some idea of how those values are related to each other, girls to boys. I think I wrote that backward. This is girls and this is boys, but you get the idea what I'm talking about here. And so when we talk about ratio here, we're looking at multiple ways to state this. One way is to say, for that example, for a part-to-part relationships. In that case, 3 girls to 2 boys, right? We could have also said, oh, there are 2 boys to 3 girls, or we could have said 2 boys to 5 children. 5 children to 3 girls. All different ways of representing that. One is called part to part to whole, and whole to part, right? Thinking about the whole situation, part to whole, part to part. And so we have that terminology to think about. Let's look at one example here real quick. 7.21. In a class 1, ratio of girls to boys is 8:6. In class 2, it's 4:3. Suppose that each class has 28 students. Do these ratios represent the same relative amounts? In this case, what we're going to see is that in one situation, in class 1, 8:6 means you can have 8 girls, 6 boys, 16 girls, 12 boys, 24 girls, 18 boys. And so we can see the same thing here. 4:3 would mean 4 girls, 3 boys, and so forth. You can see as it goes up in its multiples of 4s and 3s. I do see some common amounts, and in this case you have 16 to 12. And if there's 12 students, do these represent the same amounts? They do in this case. 8:6 and 4:3 represent the same amounts. There's 28 students. This would be 8:6, or this would be 4:3. But we also know that those are equivalent values if we wrote that as a fraction, which is one way that we write ratios. You can write ratio as a fraction.